Hello all. This presentation gives a brief overview of the various challenges which are prevalent in the medical imaging domain. So the challenge which I'll be giving an overview of today is the AutoImplant challenge. It is organized by MICCAI, which is among the leading conferences in the field of medical imaging. So moving on, the first thing that we have is the problem statement for the auto implant challenge as devised by MICCAI is our task is to generate data-driven algorithms for automatic skull defect restoration and implant generation. So basically, our aim is to generate a cranial implant for a defective skull. So it can be modeled in two ways. The first one being either as a volumetric shape completion task, where we will be impainting the inside of the defected skull to restore the defect. The second method is to generating a three-dimensional implant directly from the defective skull. So both the approaches will be evaluated using the dissimilarity score and the Hausdorff distance. Moving on to the data set. The data set which is provided for training consists of around 100 data pairs of skulls, each with dimension 512 cross 512 cross Z, where Z is arbitrary. So with artificially generated skull defects and implants. So basically what they've done is they've taken the CT scan of a complete skull, and using some segmentation techniques they have removed the a part of the skull to generate a defect and its corresponding implant. Now each pair has a complete skull, a defective skull and an implant corresponding to each subject, and we have 100 such subjects. The testing data also consists of similar data pairs. It has around 10 subjects which have in which defects have been generated artificially, and the implants as well. Now, apart from the testing and the training dataset, they have also provided 10 more data pairs with more complicated defects which are suited for a real case. So overall, there are total of 110 test cases. The data augmentation is also allowed, but it needs to be documented if it is being used. Now, apart from the dataset and the challenge statement, they have also provided us with a baseline implementation of the MICCAI auto implant challenge as well. Now, the baseline implementation is done in three steps. What they do basically is they have used an auto encoder network to infer a coarse implant directly from a coarse defective skull. The coarse defective skull they have obtained by downsampling the original skull, which is provided within the data set. So secondly, what they've done after getting the coarse implant, they have defined a region around it, a bounding box around it, and then upsampled it to the original scale in order to localize the defect which is present in the original defective skull. Now, this adds in extracting the region of the defective skull for which the implant is supposed to be generated. Finally, they are feeding this localized defective skull which contains the defect to a second encoder decoder network which learns to infer the fine implants from the bounded region of the high resolution defective skulls. Now, the workflow diagram which you can see right now, it is a more intuitive explanation of how this thing works. So as you can see, like the first step is the defected region localization, which they do by inferring the coarse implant. Finally, they get the defected region extraction with the help of the bounding box, and they finally try to predict the fine implant. Now, looking at the results of the final baseline implementation, the for the N1 encoder decoder architecture, the dissimilarity score, Hausdorff distance, and reconstruction error were the metrics which were provided for the baseline implementation. So their values are, as you can see in the slides itself, 0.0897, 5.44, 0.2% as the reconstruction error, and similarly it is for the encoder decoder architecture. Now, the conclusions which we can draw from the baseline implementation are that although this performed fairly well on the artificially generated defects on the training testing set, it performed pretty poorly on the complex defects which were provided as an additional set to the original data set. It is also stated that N1 performed well on all test points, but N2 failed to perform as well. Also, since anyone was trained on complete skulls, it seemed to memorize the skulls, which led to some overfitting of the model. So, with this, the entire summarization of the auto implant challenge is more or less done. And finally, these are the references which I referred in order to get a knowledge of what the challenge is like. And that's all. Thank you.